Okay, thanks, Bill. Our first real talk this morning will be by Dr. Ting. He's going to be talking about Java eForth. So, Dr. Ting, the screen is yours.
Okay, thank you. All right, let me get the screen. Share. Okay. Oh, let me just start the show. Everybody see the PowerPoint? Do I have my audio on?
Yes, you're fine, 100%.
Oh, okay. All right, thank you. Okay, and this morning I'm going to talk about Java eForth 108. And there are several javaEforth already implemented. And there were even an eForth implementation in Java by Michael A. Lush in 1997. I went through most of them, download them, and try to open the zip file. They are all very complicated. And with my knowledge of Java, I just couldn't understand them all. So I thought I want a very simple javaEforth modeled after javaEforth 6.14. And I wanted every fourth word to be an object. And so I try to experiment with Java, and the first thing you need is an IDE, because Java is really difficult to work in the console. So an IDE like Eclipse from IBM is very handy. Everybody knows that JavaScript is no Java. After I learned a little bit of Java, I realized that the JavaScript is actually a C script, okay? So it just expanded C to be more interactive. Objects in JavaScript are not objects, but very flexible arrays. And it's this very flexible array which allows you to do lots of things, kind of like object-oriented programming, but not really. So start work on eForth. For eForth 101, I did some initial experiments on stacks. And the eForth 102, I talked to Brad Nelson a lot, and he made it a 4-function calculator. So the interpreters kind of work quite well. And then I talked a lot with Sean, and Sean took my code and made it a real forth. And the eForth 106, I start to build on the basis of Sean's forth, and try to put the whole eForth onto the system. And the eForth 108, which is the latest version, I aligned it with the javaEforth 6.14. Eventually, when we finish this project, we will probably release it as a javaEforth. So in the javaEforth objects, all forth objects have the following attributes. It has a name, it has a token, which is a sequential ID. And the PF used to be the parameter field. It contains an object list. And the QF field, it has a data list. And the literal field is a place to store a string for string literals. And immediate field, it has a flag, which indicates whether forth is in the compiling state or in the interpreted state. Okay, so the eForth 104 or 108, I implement a single method which has a giant switch structure to execute all primitive words. And the default method in this switch executes colon words. And constants, variables, and arrays, according to the suggestion by Sean, are all implemented as colon words. So the nice thing about it is that this eForth, this Java eForth, has only two types of words: primitive words and colon words. All primitive words are constructed by class code, and colon words are defined by the user. So anything the users would do a colon definition, and it's executed as a token list. And the very nice thing about Java is that the interpreter gets very simple. And the outer interpreter is in the main method, which is written out in Java. And the most interesting thing is the parser. The parser is a single command in Java. You use the scanner class, and you have input methods, and in it, the next method, just read the next word, parse out of the input device. So this is, I don't have to do anything. I just ask for the next word, and it gives me. To use in next, however, there's price to pay. To make use of in next, I sacrificed the universal forth prompt OK and the opportunity to show the contents of data stack. This is what I really wanted. I think all forth should always display the data stack. That way, the user, the stack will not be a mystery to the user. Okay, here is the outer interpreter, okay, written out in Java. And it is just a huge loop, getting one word in and try to interpret it. This is actually what I call the evaluate. You just look up the dictionary. If the word is in the dictionary, and it is, it just executes it. If it is in the compiling mode, it will compile that word. If the word is not in the dictionary, then try to convert into an integer. And if you have the integer, if you are in the compiling state, compile a integer literal. If not in the compiling state, just push it on the stack, and then go back. So this is very pleasant. Only one screen of code. The interpreter is even more interesting. Sean Chen contributed a beautifully simple interpreter to process nested token lists, and which is just this few words. So here, for is a loop. It goes through all the token list, which is in this word list, word array. Just pick up every word there and then execute it. Beautiful. However, I couldn't, it works in shunt system, but in a regular forth system, we need to handle the control structures. And this symbol interpreter assume we have a linear list you execute from beginning to the end, but this is not how forth work. So the inner interpreter, I have to expand it to handle the structures. And so I have to have the word WP to point the current word, and IP pointing to the current object that's being executed. And so it's still this getting into the XT execution field, okay? But it has to know where it is in that token list, so that it can branch back, branch forward, and do all kinds of things. So this is what a regular forth must have. And of course, the WP is pushed, WP and IP is pushed down to the return stack before you process a list. And after you are done with that list, you restore WP and IP from the return stack. So the in the PF field, each word object has a each word object has a sequential ID, which we love because the token identifies the word internally. However, this because we got a big structure, big switch structure. Yes. The colon words are or compiled object list. It's not token list, because it's much more convenient to compile object list than to convert the object into token and tokens back to object. So, but the token, I still use token because tokens are still needed to look up objects in the dictionary. But I think eventually we probably will get rid of the token completely. So in the object list, we have the PF field attributes contains an object list, and forth needs these literals in the object list. We need to have integer literals, string literals, and address literals. So string literal is a do lit. You put that do lit and followed by this the integer, and you do the do string followed by a string, and the address list is used by a branch, zero branch, and do next. So these literals, address literals are required to build control structures. And the integer and the string literals, they are required to handle integer and strings when the token list is processed. So here, this is how I implement the literals in the object list. So object do lit, it uses the QF field to store the integer. So the integer is not another object in the object list. It's absorbed into the do list object. And the object do string and the dot string contains string in their literal field. This is the reason why I have to have a literal field in the class. And the object branch, zero branch, and do next have their branching address stored in the QF, so that when branch is executed, it took the target address in the QF field and then jumped to that address. So this is the way I do the literals. And when I'm implementing the eForth system, I always test it with these lessons. I wrote 17 lessons and tutorials, basically to teach people how to use the eForth system. And I'm using these 17 lessons to verify that eForth 108 works properly. And it's interesting that the entire file can be copied and pasted into the console window in Eclipse to exercise eForth 108. And I will do a demo with after I get through the slides. Okay, the conclusion, the eForth 108 proves that the fourth works as true objects. And doesn't have to be the fake object in the jEForth. So eForth 108 is logically correct, but it can use lots of improvement. So I'm just working at the level of my understanding of Java to implement it. But there are lots of things I don't understand. And if I study more, I probably can improve it. And I hope you guys can help as well. Sean and Brad did lots of help in hand-holding for me to get through this project. It is my first Java project, and it shows my lack of understanding of this extremely complicated language. Okay, let me just get stop sharing and oh no, let me get out of this thing, okay? And here I want to show you the Eclipse. Okay. Oh, I don't need that screen that big. Okay, Eclipse has the packages, the projects, and this is the editor window. And I currently have the eForth 108 opened. So you can see this here, the package, and I have stack and return stack and dictionary and a few other user variables. So here, it instantiated objects and then add them to the dictionary. So you just instantiate all the primitive words and put them into the dictionary. So this is how the dictionary is built. And then here is the outer interpreter, which I've shown you. I just strip off all the comments and blank lines to make it fit one screen. But the code actually is quite nice, quite tight. And then here is the primitive word class. The class is code class, and it has a name at the PF, a QF, as literal, as immediate, and has a token. And this is the constructor. So most of primitive word, you just have a name. And if I want to construct integer literal, I use this constructor. And if I want to build a string literal, I use this constructor. So, and then there's there's only one method in this class, but this method is a giant switch, which would instantiate all the primitive words. Okay, so all the primitive words, just like just like Sam Chen did in the javaEforth, all the primitive words are written in Java. And here is how you build the structures. And here's the defining words, colon, semicolon, and create a variable and a constant. And all the fetch and
I'm in a conference.
okay. And here I need to define arrays because the QF field, if for constants and the variables, you only need one integer in that field. But if you want to work with arrays, the PF field is actually a big array. It can be as big as you want, okay? So this would allow you to declare an array and fill in as many integers into that array. So I think I haven't tried out the does, but the does is very simple. It just turns on the compiler. It will work its magic very easily. Okay. And some tools, C and .s and C. I need .s because I cannot display the stack automatically. But it works just a regular forth, just that you don't see the OK, which I think we will miss a lot. Okay, so all these cases are primitives, and if the interpreter finds a match of name, it will just go execute it. If it cannot find the name in this big switch, it assumes it is a colon word and use the colon interpreter. This is the nest routine, which I show you. Okay, so that's the entire forth system. It's not too bad, less than 500 lines of code. Okay, and I just want to show you. Okay, the other thing I want to show you is this is the lesson 108. Okay, well, I got 17 lessons there. Hello world, of course, the first lesson. And then the FIG, it just writes out the big FIG characters in stars. Okay, and then all the lessons. Okay, and if I select all of them and copy them, and then move on to the to here. Okay, I push this button. Oh, hey, come on, Java. Okay, it signs up. So Java 1.08. And if I paste, you can see all the lessons, all 17 lessons were executed or were compiled. And then you can see here is the multiplication table. And here is the May 2021. You see the calendar is correct. And we are at May 22, which is a Saturday. Okay, and the guess again and all these things. So this just shows that the system essentially worked, but I haven't got into the create thus and the array, but I think they are most likely working. And okay, this is the Forth in Java. And I thank you for your patience. And if there's any question, I will be glad to entertain it. Okay.
Okay, let's open up the floor for questions.
Okay, I think it's quite clear, right?
What's the performance like?
Beg your pardon?
What's the performance like? Performance, how fast does it run forth? In other words,
Okay. Yeah, I tried the empty loops. It's 10 million empty loops a second. Not too bad.
okay, try this.
I can improve it. I think we can improve
try
it.
this. Do test colon I drop loop semicolon and see how fast it'll iterate through the loop.
Okay, I didn't try it. Okay, but the empty loop, just the empty loop, I can do 10 millions of them in a second. Okay.
So is it faster than a regular implementation of loop of Forth?
Yeah, it is comparable to other eForth implemented in high-level languages. It is not as good as if you implement the things in the assembly. And of course, if you run it on a real Forth engine, it's going to be much faster because the loop is only a single instruction. Okay, you do run as many clocks as your machine can afford.
I was going to ask, does it support file I/O?
No, it doesn't support anything. It just has the console. But you get, as I show you, I can paste a very big file into the console and you compile it. So you don't need a file interface.
Well, what if I wanted to access the USB?
Well, that's your problem. Okay.
Okay.
But Java has all the facilities to access the system resources. So you can call onto Java to do all this for you.
Okay. So I'd have to put a new couple of code words in there or something like that to deal with that.
Yes.
All right.
Yes.
Okay.
Okay.
So it's possible. It's just not.
It's possible. It's not. I think this. I need to put the link into the chat. Okay, so you can actually download it and then play with it. Okay. Yeah. Let me go to do the link.
Any other questions?